So welcome back to Ask DRTK, and today I want to share with you a build that I've been working on. It's my audio video test center where I can test streaming gear, audio video components, scalers, capture cards, really anything to do with audio video streaming and recording. And so in this video, I'm going to share with you what I can do with this build, the build itself, and the gear that I've been using, as well as the finished product. So the first thing I did was identify where I'm going to place this test station, and I had one corner in the studio that was being underutilized. So what I did is clear that out, and the first thing was to put a TV onto the wall, and I'll go through what I have here in the gear section later in this video. But what I have now is I have a cabinet there that will house some of the gear, some of the various equipment that I need for testing. Then I went ahead and put a countertop there that's going to house some of the equipment on top that I need, the switches, matrices for video, as well as a couple of the computers that I use for testing legacy, composite, and component output. And just to give you a sense of where this is in the room, we'll switch over here to a room shot, and you can see that I have this just over my left shoulder in the far corner, where what I've done is basically set this up so I can see it from my workstation. It's also near to my computer so that I can get things connected when I want to capture. And we'll go over it in a little more detail in the gear in terms of what I can actually do with this. But I just wanted you to have a sense of where this fits into my studio space. Now, in terms of what I can actually do with this test bench, I can actually test scalers and converters, and I can see what the compatibility of the inputs and the outputs are. I can also see if there's any latency. I can look for the quality of the up conversion or down conversion that's happening. I can also test one output versus another. So if we want to compare composite and component, or component and HDMI through various types of conversions, I can capture all of this onto my PC in either HDMI or AV format. And ultimately what I can do is assess the performance of all types of streaming gear, whether it be for live stream or for recording. And the idea is to be able to determine how gear performs in different applications. And this video isn't an actual test, but it's just a build guide to show you what I've done. But just for example, I can do direct side-by-side comparison of latency between direct signal and scaled or converted signal. Let's pause the video here and I'll just back up and I'll show you what I mean. Watch as I scrub through the footage. Notice how the display changes first on the top and then on the bottom display. That's the difference in the native signal versus a scaled signal. So now that I've talked a bit about what it can do, let's go over the gear that I'm using to make this happen. So first we'll look at how I'm switching all of the various inputs. So the first thing I'm doing is the HDMI switcher. It's the EasyCool 4x2 HDMI matrix. This has HDMI input capabilities of 720p at 3060 and 120 Hz, 1080p at 3060 and 120, 1440p at 60, and 4K at 60 Hz. The output will either be a pass-through or the scaler will actually downscale 4K to 1080p. It doesn't upscale and it doesn't scale any of the other resolutions, but if we have a 4K input source, we can output at 1080p. Now the video format is HDMI 2.0 444, a bandwidth of 18 gigabits a second, and of course it supports Dolby HDR Vision. Now in terms of the audio, it's digital 7.1 with Atmos and DTS:X support, and it can also de-embed SPDIF 5.1. And so this unit will handle all of the HDMI component switching. So this could be scalers upscaling to HDMI, direct HDMI sources, or any other type of application we need where it's an HDMI input. Now I also have a controller for component video input. And for that, I'm using the ShinyBow 4.2 video matrix. And this has 4 5RCA individually selectable component inputs, and it has 2 individually selectable 5RCA component outputs. So this allows me to move my component sources around to 2 different outputs. Could be the TV above, could be a monitor, or could be an upscaler or converter from component to HDMI. And this uses, of course, YBP-PR format. A little bit of details on the screen: 480i and P, 576i and P, 720p, and 1080i and P. Has a video bandwidth of 250 megahertz, which is plenty for any sort of component application. And so with this device, again, I can move my component sources around So whether I want to test direct output performance versus scalars, one scalar or converter versus another, and then capture them side by side in HDMI format, I can do that with these devices. And because many retro devices use composite video, I'm also using the Changbao 8x2 composite AV switcher. Now this has 8 inputs with 3 RCAs, they're individually selectable, and provides 2 outputs that are mirrored. And it supports all SD composite formats. So while this isn't a matrix, it doesn't allow me to split different composite signals to 2 outputs. What it will allow me to do is again compare composite video direct versus composite video that's been scaled and converted. And so we can take a look at latency difference, and we can take a look at quality difference. And we can see it in real time on my test bench as well as captured into the PC. Now, as you can see, I'm using 3 separate monitors. I have a TV on the wall as well as 2 monitors on the test bench. And the first one is the eYoYo EM12A. This monitor is TFT LCD. It has a 12.1-inch screen with a 4:3 aspect ratio, native resolution of 800 by 600. And what's important about this monitor is it has HDMI, BNC, VGA, AV, analog audio, as well as USB inputs. And so this monitor allows me to do a lot of intermixing of sources for direct connection, again, that I can compare versus scaled outputs, but it will also accept the outputs from many different types of scalar and converter boxes. The second monitor I'm using is a Sony SDM HS74P DVD-I and VGA monitor. This monitor is also TFT LCD with a 17.4-inch screen and a 4:3 aspect ratio. This monitor's native resolution is 1280 by 1024. And the idea of this monitor is, of course, it supports a variety of ranges of VGA signal for us to be able to test scalars with. And it also has the DVI-D input, so we can use that to evaluate various converters and sources. And finally, I have an LG 32LH20 TV mounted to the wall. This TV is TFT LCD, has a 32-inch screen with a 16:9 aspect ratio. Native resolution is 1366 by 768, but it does have a just scan capability of taking 1080p input. Now this TV has HDMI, component, VGA, AV, analog audio, as well as optical audio out, and it supports HDMI of 720p, 1080i, and 1080p, with component input in those same ranges as well as 480p. And it'll accept frame rates of 24, 30, and 60. And the idea of this TV is to be able to look at a common use case where we may want to connect a retro component up to a television, maybe with component or composite input, and we can compare that against scaled and converted output from HDMI. And again, the idea of real time here, as I showed in my latency demonstration earlier, where I can have 2 video sources simultaneously. And the idea is that knowing the latency of the various components, I can isolate out the difference of any converter or scalar only to figure out what its performance is. Now, while I'm going to be using this test bench to evaluate the performance of various scalars and converters, I do have a few standard devices built in here that I'm going to use to compare against. And the first is the RetroTink Mini. The Mini accepts composite and S-video and converts it to HDMI as well as does scaling. It has output resolutions of 480p and 576p, and of course it accepts NTSC, PAL, PAL60, and CCAM. This is a line doubler, so it increases the quality, and so this is something, again, if we're comparing other converters against it, we want to test to see just what that difference in quality is. I'm also using a RetroTink 2X Pro. And while it has component input as well as composite inputs, the interesting thing here is we can also test 240p off-spec signals as well as component signals. And this one also outputs 480p and 576p. Using a line doubler with a variety of filters, this unit has a little more ability to improve and affect the output that we're getting. But the idea here again is that I can use this as a benchmark to compare other scalar converters against. And to include something that's more in the inexpensive range for component converters, I've also included the SunEtch component to HDMI converter in my standard setup. You may have seen a recent review I've done on this box, and I really think it performs above its price class. This unit has an HDMI output and accepts component input. It works with 480i and P at 60 Hz, 576i and P at 50 Hz, 720p 50 and 60 Hz, and 1080i and P at 50 and 60 Hz. And the interesting thing about this unit really is all of the selectable output resolutions for an inexpensive box. The SunEdge converter has 800 by 600 at 60 Hz, 1024 by 768 at 60 Hz, 1280 by 1024 at 60 Hz, as well as 720p and 1080p at 60 Hz. So a lot of output frequency ranges for an inexpensive box. This can really help out if you're trying to use different types of displays that have different scaling built into them. Ideally, we don't want the display doing the scaling because that tends to introduce a lot of lag. And finally, to test composite and S-Video up conversion to VGA, I'm using the WeStar S-Video and Composite to VGA scaler converter. This unit accepts composite and S-Video and converts it to VGA. It also accepts VGA for picture-in-picture. Now, what's interesting about this unit is it also accepts off-spec 240p signals. Now, this includes a variety of output resolutions and also has an auto comb filter. This has 3D motion adaptive deinterlacing as well. And so again, a good place to start when we're looking at composite and S-Video up conversion to VGA. And finally, I have 2 capture cards built in as the standard for capture. Now, I will use this bench for testing a variety of other capture cards, but I have these as a benchmark for performance so we can do on-screen comparisons after the fact. Now, the first one, of course, is the Elgato 4K 60 Pro Mark II. This is a PCIe capture card with a variety of input and output resolutions. Now, the pass-through will be available here to show on the TV above the test bench, but really the idea here is mostly capture with this card. The interesting thing about this unit, of course, is it is YU-Y2 capture, so we're going to get an uncompressed capture. It'll give us the cleanest comparisons possible without artifacting. And because I also want to capture composite video without pre-conversion or upscaling, I'm using an AverMedia CO39 composite capture card. This accepts all standard definition formats. It does output in H.264, but when you consider that composite already has quality issues, this is about the best that I can do in terms of getting this directly into the computer. And while it's not complete, I just wanted to give you a view of what the test bench looks like a little bit more close up. Here you can see the 3 screens we're using. I have a couple of computers on the top of the counter for testing those legacy signals, and we'll have various consoles on the bottom that are connected into the matrices. And again, this video is kind of the first in a series of studio tour videos. I wanted to give you an idea of what I've built so that I can test the audio and video sources, converter, capture cards, scalers, etc. for streaming and recording. I hope you enjoyed this video and found it interesting. If you did, think about smashing that like button. And as always, thanks for watching, and I'll see you next time.